All right, so we've looked at fractions. Now let's look at rational expressions. So we're going to add two rational expressions together that have the same denominator. Okay, all we're going to do is we're going to add our numerators and then keep that same denominator. And again, here in this case, it's c. That's going to be non-zero, otherwise it doesn't work. And then so we'll have a plus b over c. And the key is once we're done, everything has to be in factored form because then things might need to be canceled out at that point in time. All right, so we look here and we're supposed to add and simplify to lowest terms. And this lowest terms means, cancel when necessary. So here we have a common denominator. So we're going to take 4x plus x, so that's going to give us 5x. 1 minus 2 is going to be minus 1 all over our x plus 3. Now we can't do anything to reduce that, so we're going to say we're done. Now here we have a common denominator. Now when we have something like a trinomial or a binomial that is something beyond just x plus 3, probably a good idea is to think about what are its factors before we get too far. So what can we do? Well, we can take x plus 5, x plus 2, because that's going to give us 10, that's going to be 5 plus 2 is 7, and so that'll be its factors. Now we just have to add the numerators, because both of these are the same. So we have now x plus 5 over x plus 5, x plus 2. Now here, this goes in here once, that goes in here once, and so we get 1 over x plus 2. And the reason why I said the factor was because a lot of times when they set up problems, they're going to make it so when you add two things together, you're going to be able to cancel in the end. All right, so what they show again is they're taking all this together. Now they're going to put it all in one line, and now we have to add all the common terms. So 4x plus x gives us 5x, 1 minus 2 gives us minus 1, again, all over the x plus 3. Now here, we're going to have x plus 5 in the numerator over this, and then they're like, oh, well, maybe we need to factor that, and so then they go ahead and factor at that point, and so then now our x plus 5's cancel, and we get 1 over x plus 2. All right, so what if we want to add and simplify to lowest terms on these types of problems? All right, well, again, same thing. It's not any different. We have a common denominator, so we have 7 plus 4, that's 11, all over AB. Nothing we can do there. All right, what about here? Well, this is going to be W plus Y, W minus Y. And same thing here, so that's our common denominator. So now if we take W plus Y on the numerator, all over our denominator, which we factored because we saw that was a difference of squares. Now we see, well, hey, that cancels that, and we get 1 over w minus y. Okay, well, it kind of looks like w anyway. And so again, they're just saying, okay, well, we're going to take it, add across, we get 11 over ab. Here we're going to say, well, that's going to be w plus y over this. And now at this point, you have to think, okay, now I can factor that into the w minus y and w plus y. Those cancel, and we get the 1 over w minus y. So again, doesn't matter what order you do things, as long as when you get done, you've reduced it to the lowest terms. All right, well, how does the difference of rational expressions work? It works the same way, except we're subtracting instead of adding. And again, our c cannot be 0. And so here the key thing is when you minus the b, when you're doing a rational expression, you're probably going to put that whole b in parentheses, and you're going to distribute that negative throughout to make it work. Okay, so let's see what that means. Well, here we have, again, common denominator, and we're going to have a minus this. So we're going to take minus this, so we'll have a minus x minus 6 over the x squared. So this is what happens, and now we're going to change it to plus. We're going to take 6 plus this. Well, 6 plus this, that 6 cancels that 6, and we just get what? A minus x over x squared. Well, guess what? That x cancels that x, so we get a minus 1 over x. Now here, this, well, that's a difference of squares. That's going to be x plus 1, x minus 1. Now again, I'm going to say, well, let's change the sign. So it's going to become plus. Distribute, that's going to be a minus, and that's going to be a plus. So we have 2x minus x is going to be x. Minus 3 plus 4 is going to be plus 1 over, now we have x plus 1, x minus 1. Well, guess what? Those cancel and we get 1 over x minus 1. All right, so now let's see how they want to show in the book. Well, in the book, they go ahead and say, okay, well, that's going to be 6 minus that. And again, like I said, what we're going to do is we're going to distribute this. And so we're going to get 6 minus x minus 6. Now our 6's cancel. And so we get minus x over x squared. Now our x cancels and we get a minus 1 over x. What about the second one? Well, we're going to do the same thing. We're going to just take and distribute that negative over. We'll get minus x plus 4 all over the x squared. So we have 2 minus the x. It's going to be x. And then minus 3 plus 4 is 1. Now we have to think about that. Well, we can, again, factor like we did up here. And then we can cancel our x plus 1s. So we get the 1 over x minus 1. All right, what about here? Okay, well, common denominator. So let's change it to plus. That's going to be a minus a. That's going to be a plus 2. So 7a minus a is going to give us 6a. And then we have plus 2 all over a plus 2. Well, now we have to think. We can factor out a 2 here, and that's going to give us what? A 3a plus 1. And that's over a plus 2. Now, I don't know that nothing cancels, so either this one or this one can be used for the numerator, and it would be fine as far as which one is correct. Now, if we wanted it most lowest terms factored out, then we'd want to have the top one. So again, they're showing now they're going to distribute the negative, and you get 6a plus 2, and that's where they leave it. I did it and factored it again because I wanted to see if it would factor out. It didn't, and so that's why I say you could leave it here, or if you want to leave it in factored form to show it doesn't cancel, then you can do that. All right, so that's all I have for this section, so hopefully that helps.